Hi, welcome to our circles review, day one. We'll be talking about the parts of a circle to start with. So remember, we have tangent lines, which touch the circle one time. We have secant lines, which touch the circle twice. Chords, which go inside the circle and connect 2 points on the circle. And then a diameter, which is a special type of chord, which goes through the center. And remember, when we talk about this, that a secant line, right, the segment inside the circle here is a chord. So they're kind of like the difference between them. All right. First thing we're going to talk about is the angles formed by a circle. So there's a few different types of angles. There's a central angle formed by two radii, vertex at the center, and the measure of the angle here is the same as the measure of the arc. So it's 360 degrees on the outside and the inside. So the angle is equal to the measure of the arc. Second one, the inscribed angle. It's formed by two chords. The vertex is on the circle, and it's equal to half of the measure of the intercepted arc. So if this is 50, the angle is going to be 25. Okay, and likewise, if we know that the angle here is 30, then the arc is going to be double that. It's going to be 60. Okay. Second one is secant angles, or formed by two chords that connect inside the circle. Kind of idealize this as the vertical angles, right? The little bow tie going on here. So anytime you have an angle formed inside the circle, right? Not even at the center, it still works. It's the measure is the average essentially. Okay, so you're going to add the two arcs and then divide by 2. Okay, so the two angles are equal, and it's the average of the two arcs. All right, so let's go through examples here. So number one, identify the angle. It's central. It's equal to the arc, so this is just 70 degrees. 2, this is inscribed, so it's equal to half the arc. So we need to take these two angle arcs and put them together, which means this is 250. We take that away from 360 to get 110. That's the measure of this arc. This angle is half of that, so that would be 55. All right, so likewise, we have the three arcs here. We have 140, we have x, and we have something. If this angle is 40, that makes the arc 80. So together, these two arcs, right, 140 plus 80 is equal to 220. That makes this 140 to get 360. Okay? Starting with this one, here we have this diameter cut into the circle, which means that this entire arc up top is going to be 180 degrees. We have 60 degrees and 40. So that means if we have 180, we're already using 100 of them for the 60 and the 40, we have 80 degrees left for this arc right here. So this angle is just going to be half of that. So that means x is equal to 40. All right. This we've talked about before, but essentially, if you have a quadrilateral inscribed in a circle, and this actually comes up on the last page over here. Where are you? Okay. That the opposite angles, there we go, add to 180 degrees. Okay. Really, what's going on here is that this 78-degree angle is forming the arc that connects from here to here. And so if this is 78, then this arc is 156. This is just 360 minus this. Okay, so this is going to be 204. How about, I feel like this should be 104 here. All right. No, 204 is right. 204, and so this is just half of that, and so this is going to be 102 degrees. Okay, but remember that the opposite angles are essentially just supplementary. So you could have just done 180, right, minus 78, and gotten the answer that way. That's kind of hard to read, so I'm going to switch screen here. Okay, on the next one, we're looking for the measure of this arc. So remember, this is formed. This angle is actually kind of related to as an inscribed angle, where it's on the circle, so it's a tangent chord. This is half of this arc. So same thing here. Okay, if I have a angle formed by a tangent line, okay, and a chord, okay, this is equal to, let's call this A, B, C. Angle A, B, C is equal to 1/2 of arc AB. Okay, that's kind of our tangent chord rule. So that's how this is going to apply to number 6. If this is 40, this is double that, so this is 80. And so this x is just 360 minus 80, and that's 280. Okay? This guy, number 7 here, is going to be applied to this theorem, where inscribed angles that intersect the same arc are congruent. So since these two angles here are both creating this arc, they're equal, and so we know x is just equal to 43. Okay? All right, likewise, central angle is the same as the arc, inscribed as half, so just half of 84 is 42, and that's the measure of x. 110, we talked about the angles formed inside the circle up here, so we know we're just doing the average. So 110 plus 60 divided by 2 is 170 divided by 2, and this is going to be 85. Here's another one where we're given the outside part. So remember, we still do the average, right? The next step here is just to cross multiply. So x plus 110 is equal to 160, so x has to equal 50 degrees. Okay, this is another same type of question, except now we have these two arcs, so really we need to know the measure of those angles. And so if this is 85, that makes this 95, and now we can do the same thing. X plus 70 divided by 2 is equal to 95. This is x plus 70 is equal to 190, so x is equal to 110. All right. You could also figure out this arc and then do the 360 from 170, just a little easier that way. Here we have a diameter cutting through, so if this is 110, this becomes 70 degrees, and then we can go ahead and do the average here. So 70 plus 60 divided by 2 is 130 divided by 2, which that makes x 65. All right, that's just kind of the angles as they relate to one another around the circle here. The second part here is angles formed outside the circle. Little review question here. So if you wanted to, actually we just did this. You don't have to do this. That was the last question we just did. So cross it out. Okay, remember outside the circle, remember where the phrase outside is different, and that means we're going to subtract. Okay, so whether it's two tangent lines, right, a tangent secant, or two secant lines, it's always the bigger arc minus the smaller arc divided by 2. 1/2 the bigger minus the smaller. Okay? Remember, you're going to follow the lines where they cross to the circle. Okay, you're going to locate the 2 points, and then it's just bigger minus smaller divided by 2. Let's look at number 15. Right? We got two secant lines, so it's just going to be bigger minus smaller divided by 2. So 140 minus 30 divided by 2. This is 110 divided by 2, and so this is 55 degrees. Okay? In number 2, we got another diameter here. We have 20 and 60, which makes 80. So 180 minus 80 is 100. That's the measure of this arc. And then we just do bigger minus smaller divided by 2. So 100 minus 20 is 80. And then 80 divided by 2 is 40. And that's the measure of x. And that's it. Okay? 17, same idea. Here we have a diameter. We know that this angle is 20 degrees. We don't know what this is yet. But we want to get it. I don't think we have enough information for this one. Well, let's try it. This is going to be really just 180, right, for the whole thing. Take away 80 plus x, essentially, right? That's just the measure of this guy. And this is x, so it should be 180, take away 80 plus x, right? Subtract another x, divide that by 2, and that should equal 20. That's essentially the concept here. So let's see how this works out here for us. So we get 180 minus, and we kind of distribute the negative 1 here, 80 minus x, divided by 2 is equal to 20. We'll cross multiply. So here we're going to get 100 minus 2x divided by 2 is equal to 20. We'll cross multiply here or here, it's up to you. We get 100 minus 2x is equal to 40. Okay, move this up a bit so you can see it. We'll minus 100. We'll get negative 2x is equal to negative 60. We'll divide by negative 2, and we get x is equal to 30. So using our formula for calculating like 180 degrees, and then minus the sum of these two, we can come up with this expression, and then we can go ahead and solve for x. Okay, here's one where we're giving us the small arc, kind of the same thing. So it's bigger minus smaller divided by 2 is equal to the angle. So cross multiply first. We get 130 minus x is equal to 50. Now, there's two options. You can move the x over to this side and move the 50 back and get your answer that way. Or like we did over here, you can move the 130 over and then divide by -1. So leave it up to you. Okay, this question with the two tangent lines is a little easy. It's kind of tricky though, deceiving, right? Remember that this arc right here, right, with the 230 makes 180, or sorry, 360. So this arc is really just 360 minus 230, which in this case is 130. So now I can do 230 minus 130 divided by 2, and that's x. So this is just 100 divided by 2, in this case, which is 50. All right, so likewise, if this is 70, then this arc going all the way around here has to add to 360 with this. So this is just 360 minus 70, which is 290. And then we just do big minus small divided by 2. And so this is 220 divided by 2, which is 110. And there's x, okay? There's page 2. And here, page 3, we're talking about the lengths of the parts of the circle. So remember, we talk about segments, we're talking about the whole times the outside. So the tangent is the whole on the outside. It's the same thing. The whole on the outside is the same piece. Okay? So this is the whole and the outside piece. This GE is the whole, and this is my outside segment. So once again, I have the external, the whole part, that's the whole line, times the outside piece, and then the whole times the outside piece. And then for the last one, when the segments intersect in the circle, you are multiplying together the two parts of our chords. So in this case, it's going to be AE, right, times ED, which are the two segments of chord AD, and then it's going to be BE times EC. That's it. Oh, ED. Okay, and that's where those are coming from. All right, so let's take a look at the first one. We've got the segments intersecting in the circle, so it's just part times segment. So it's x times x minus 8 is equal to 4 times 5, and this is going to be a quadratic, so it's going to be x squared minus 8x is equal to 20. Now remember, at this point, we want to get everything equal to 0, okay? So we'll move the 20 over. We get x squared minus 8x minus 20. We want to put it in descending order, and then we're going to look to factor. So I want two numbers, right, that are going to do a times c. They're going to multiply to give the number in the end, which is negative 20, and add the number in the middle. So in this case, our options for 20 kind of limited, 21, right, 2 and 10, 4 and 5. So here we want to do 10 and 2, and we want the 10 to be negative. So it's x minus 10, x plus 2 is equal to 0. We drop our wall, do a zero product property, and we're going to get our two answers. And now remember, this is a length, right? So we are not going to accept this as an answer. There's no negative lengths. And so my answer here is 10. All right, on to number 2 here. So remember, it's outside is different, right, for the angles. Here we're doing the whole times the outside piece. Okay, so the whole is x plus 2. The outside is x. The whole here, right, is going to be 10. And then the outside piece is 6. So this is just going to be x squared plus 2x is equal to 60. We will move the 60 to the other side, right? And then we're going to look to factor. So what are the numbers that multiply to give you 60? So we have 1 and 60. We have 2 and 30. We have 3 and 20. We have 4 and 15. 5 and 12, right? 6 and 10. Any other number is going to work here. I think we're kind of stuck at this point. Here's another option for you if you're kind of not sure what to do. If you take your calculator, okay, open up a graph and type in my equation. So it's going to be x squared, so x squared, and then we're going to do plus 2x, okay, and then minus 60. And we're going to hit enter. You can go to graph. And what we really want to do, and this is a little bit different than yours though, is we want to figure out where this is crossing the x-axis here, okay? So this is called a 0. Now my calculator is a little bit different. You're going to go to menu on yours, analyze graphs, go to the 0, and you're going to want to pick your window on here, okay? For mine, it's going to be, this one, calc 0, left bound, over there. And there's my answer. And so you can see this one's not a nice number, right? Not going to factor really well. So we're kind of lost here. So what we can do is we can do completing the square, right? Which means I'm going to want to go back to this step, okay? So what I'm going to want to do is take this x squared plus 2x equal to 60, and I'm going to want to do that b over 2 squared, right? B over 2 squared. And I'm going to want to add that to both sides. So this is 2 over 2 squared, which is really just 1. So if I add 1 to both sides, I get x squared, right, plus 2x plus 1 is equal to 61. This becomes x plus 1 squared. And then I'm just going to take the square root of both sides. So x plus 1 is equal to the square root of 61. And I'll subtract 1. So x, and remember this is plus or minus, is equal to the plus or minus the square root, well, sorry, let me try this again. Negative 1 plus or minus the square root of 61. So those are going to be my two answers. All right. Now, negative 1 plus the square root of 61. There's my 6.8. And if you remember, when we did the 0 on the graph, right? We got that same number, 6.8, right? So that's our answer right there. If we do negative 1 minus the square root of 61, we get the negative answer, which we don't want. So x is just going to equal 6.81024966. On the exam, your quadratics should factor out, okay? Just a quick review of completing the square, but they will factor out for you, okay? This next guy, same thing, right? So here I have the whole, which is x minus 3 plus 12, right? Which is really x plus 9, and the outside is 12. So its tangent squared is equal to the whole, which is x plus 9 times 12. So I get x squared equals 12x plus, and this is really just going to be, I believe, 108. And so we'll move the 12x and the 108 to both sides. We'll subtract it to move it over. So I get x squared minus 12x minus 108 is equal to 0. And now I'm going to look to solve. Now remember, I'm going to do the factor option here. So I'm going to think about what are the factors of 108. So like there's 1 and 108, which isn't going to work. Okay? If I take 108 divided by 2, I'll get 54 and 2, which isn't going to work. 108 divided by 3 is 36. That's not going to work because it doesn't give me 12, right? 3 and 36 won't give me 12. 108 divided by 4, 4 and 27, still not going to work. 5 is not going to work. 6 works, 6 and 18. And hey, look, if I subtract them, I can get 12. So by using the factors of 108, right, what numbers multiply to give you 108, you can compare those. And you just divide one of the numbers you think divides into it, multiplies 108, and if it comes out to be a whole number, right, if I try 5, you're going to see I'm going to get some decimals, so that's not a whole number. So I know I'm going to use 6 and then 18. So it's negative 108, negative 12, and then it's negative 18 and positive 6 to make this happen. So this is x minus 18, x plus 6 is equal to 0. X minus 18 is equal to 0. If that happens, then x is equal to positive 18. Or if x plus 6 is equal to 0, x is going to equal negative 6. And so we reject this answer. Once again, no negative lengths. And so we take our answer of 18. Okay, that's it for today, guys. The other common theorems that are going to come up that you might see, remember parallel chords intersect for form congruent arcs. All right. We talked about inscribed angles that intersect the same or congruent arcs are congruent. We talked about how congruent chords form congruent arcs, and also if these two are connected, they also form congruent central angles as well. Okay. If the chords are the same distance from the center, then they're equal. Okay. Our hat rule, right? Two tangent lines that intersect from the same part of the circle are congruent. And also, a tangent is perpendicular to the radius at the point of tangency. All right. The circle that's inscribed in a semicircle is a 90-degree angle. Remember, if this is 180 up here, that has to be 90. The opposite angles in a quadrilateral are always supplementary. So B plus D is equal to 180, and A plus C is equal to 180. Right, ones across from each other. We talk about tangent perpendicular to the radius. And the last one, remember, if you have the arcs always add to 180 degrees. So if they give you a ratio like 1, 2, 3, just put an exit on those and create your equation and stuff. All right, guys, that's it for me. Thanks for tuning in, and we'll see you next time.